Okay, so let's start the chapter properties of concrete continuation part as a water cement ratio. See, the water cement ratio is nothing but the water cement ratio means it is the ratio between the weight of water to the weight of cement that is used in the concrete mix. That means for a particular grade of concrete, what is the weight of cement that we are taken is, and also what is the weight of the water we are taken, that we are call it as a water cement ratio. Normally, the water cement ratio falls under 0.4 to 0.6 as per the IS 10,262-2009 for the nominal mix. That means for the grade of M10 to M25, the leakage of motor through the form works also were considered. What are the factors which is going to be affect the water cement ratio? Definitely, the factors which are affecting the water cement ratio is the quality of the cement which we are going to be used. Then second is the size and shape of the aggregates. And third is the surface texture of aggregate, then concrete mix proportions, grading of aggregate, and also the use of the admixture. Then what do you mean by the durability? It is the property of concrete by virtue of which the concrete is capable of resisting the disintegration and decay. Then what are these factors which are going to be affecting the durability? First is the environmental, such as the extreme temperature. Second, the attack of natural or of about industrial liquids or gases. Third is the permeability in concrete. Fourth is the alkali aggregate reaction. Fifth is the seawater attack. And the sixth is the admixture. Next is the impermeability. It is nothing but the resistance of concrete to the flow of water into the pore spaces in it. The concrete should have very high permeability in nature. Then how this impermeability can be achieved by? Let's see. The impermeability can be achieved by either by proper curing method or else by using a concrete with a low water cement ratio. And third is of about proper compaction. And also fourth is the selecting well-graded aggregate. Next, what do you mean by this shrinkage? Shrinkage is nothing but the volumetric. It is nothing but the volumetric reduction of the concrete. It is termed as a shrinkage. The concrete should have about a very high impermeability in nature. See, then what are these types of shrinkages are there? Why that volumetric reduction in concrete surface will be taking place? Let's see. There are 4 different types of shrinkages. One is the plastic shrinkage. Second is the drying shrinkage. Third is the autogenous shrinkage. And the fourth is the carbonation shrinkage. Plastic shrinkage. This plastic shrinkage is due to the appearance, the loss of water due to the evaporation from the freshly placed concrete, while the cement is in a plastic state. This plastic shrinkage is higher at a higher rate of evaporation of water due to the temperature. This plastic shrinkage of concrete is higher at a higher cement content also. Plastic shrinkage we can commonly see where there is about a yielding of former. That means if there is a gap in the former also, definitely it would have caused the shrinkage. Next is the bad proportion of concrete mix. Definitely, if the proportionate of the concrete is not maintained properly, it would have gone the shrinkage. Then how do we prevent the plastic shrinkage? So it can reduce by preventing the loss of moisture in concrete, either by covering with the polyethylene sheets immediately, and also some quantity of aluminum powder also we can add it to prevent the shrinkage. And in some places, if shrinkage is occur, reverberating the concrete can be done in a controlled manner. And also that in practically, we will do some broom finishing the surface, like the roughening of the surface to prevent the plastic shrinkage. Then what do you mean by the dry shrinkage? The shrinkage that takes place after the concrete has been set and it has been get hardened. So that type of concrete we are call it as a drying shrinkage. A part of this shrinkage is recovered on immersion of concrete in water or storage under the wet condition. Then what are the factors which are going to be affect the dry shrinkage is water cement ratio. Next is the cement content and is a humidity. Next type of aggregate and shapes which we are going to be used in the concrete. Then is a curing method. Definitely curing method will impact more on it. Type of cement and also the type of admixtures. Next is the drying shrinkage. So then how we are going to control the drying shrinkage? See, in order to control the drying shrinkage in the concrete, first we should maintain the humidity of the concrete. So you have to maintain the humidity. Definitely we can reduce the drying shrinkage, and also by adopting a low water cement ratio and to avoiding very fine cementitious materials can also be added in a concrete to prevent the dry shrinkage. Sometimes we are using of about a steam curing method also to prevent the dry shrinkage. Then what do you mean by the autogeneous and carbonation shrinkage? An autogeneous shrinkage is defined as the concrete volume change without any moisture transfer to the environment. Okay, the autogeneous shrinkage is defined as the concrete volume changes without any moisture transfer to the environment. It is the result of the internal chemical reactions of the concrete component. It is the result of internal chemical reactions of the concrete component. Then what do you mean by the carbonation shrinkage? This carbonation shrinkage occurs when the concrete is exposed to the air containing carbon dioxide. Okay, when the hardened concrete is exposed to this type of carbon dioxide air, the weight going to be increased and the concrete undergoes irreversible carbonation shrinkage. It is called as a carbonation shrinkage. Then what are the factors which are going to be affect? First is the water cement ratio. Increase the water content in concrete, almost it will get double the shrinkage. Fineness of cement, definitely low heat and also early strength concrete shows more shrinkage, but for finer the cement, greater will be the expansion. Then third is the relative humidity. Concrete kept on 100% relative humidity for any length of time will not cause any shrinkage in it. Fourth is the type, amount and gradation of the aggregate. Smaller the size of aggregate particle, definitely the greater the shrinkage. Fifth is the type of cement. Generally, the rapid hardening cement shrinks more than the other cement. Admixtures also. This admixture will be increases the water requirement in concrete. Definitely that would have been increased the shrinkage. What do you mean by the creep? See, creep is nothing but like it is a deformation. Okay, it is nothing but the deformation of the structure under a constant load. Generally, the creep develops in a concrete at the beginning and it will gradually decreases with the time. When a load is to be applied to the concrete, it experiences an instantaneous elastic strain which develops into the creep strain if the load is sustained. And what are these factors which influence the creep? Let's see one by one. Okay, the stronger the aggregate, the more is the restraining effect and hence the less the magnitude of the creep. That means if you use the more stronger the aggregate, definitely we will reduce the magnitude of the creep and increase from 65 to 75% of volumetric content of the aggregate will decrease the creep by 10%. Then what are these mixed proportions? It can be said that the creep increases with the increase in water cement ratio. It can also be said that creep is inversely proportional to strength of concrete. What do you mean by this influence of age? Age at which a concrete member is loaded will have a predominant effect on the magnitude of creep. The moisture content of the concrete being different at different age, also it influences the magnitude of the creep. Then let's see that what do you mean by the alkali aggregate reaction that we are going it as a ASR, a complex, okay, a complex and heterogeneous, a complex and heterogeneous chemical reaction between the alkalis in the concrete and alkali reactive particle in aggregate, leading to the formation of alkali silicate gel, which expand and causes the crack in the cement paste. Then what are these factors which are going to affect the alkali aggregate reaction is cement with the higher alkali content can also promote the reaction. Second is the higher the water content make concrete is very porous and there is a possible of cracking. If aggregate has a smaller particle size, reactions will be takes place more. And fourth is the exposure condition. Then how do we control the alkali aggregate reaction? Definitely, we can control the alkali aggregate reaction by use of non-reactive type of aggregate. First, we can use of non-reactive type of aggregate, and also we can use the blended, that means cement plus slag cement, and also some use of corrosive admixtures like fly ash, silica fume, etc. Fourth is the limiting cement content in the concrete mix. And fifth is the selecting low alkali cement for making the concrete. Then what do you mean by this chloride attack? Students, you can check in the beam, actually there is a corrosion. Okay, the concrete itself, the color of the concrete is also going to be changed. Then what is this? The chloride have a little effect on the hardened concrete, but they increase the risk of reinforcement corrosions also. That means the corrosion of the reinforcement will be initiated when the chloride ion concentration at the steel reaches, then it is called as a threshold level. These chloride salts can enter the concrete in two different ways. It may present in concrete itself, or it can penetrate into the hardened concrete wherever it is permeable and reach the reinforcement at isolated points. What do you mean by this acid attack? Acid attack in concrete by dissolving both hydrated and unhydrated cement compound as well as calcareous aggregates. In most of the cases, the chemical reactions forms water-soluble calcium compound, which are then leached away. The places where this acid attack means the concrete used for the storage of many kind of liquid, like in some industries also. It also encountered under the industrial conditions, and certain sewerage water also causes the deterioration of the concrete. Next is the sulfate attack. Sulfate attack on concrete is a chemical breakdown mechanism where sulfate ion attack the components of the cement paste. The compounds responsible for sulfate attack on concrete are water-soluble sulfate-containing salts such as alkali earth, that means calcium and magnesium, and alkali, that is sodium and potassium sulfates, that are capable of chemically reacting with the component of the concrete. Then what do you mean by this non-destructive testing, that is a NDT test? See, these kind of testers generally we perform only after the structure has got completed. That means for an existing structure, we are going to conduct certain non-destructive testing to check the quality and also the strength of the structure. This non-destructive testers of concrete is a method to obtain the compressive strength and other properties of concrete from an existing structure. This test provides immediate result and actual strength and properties of concrete structure. This non-destructive method may be categorized as penetration test, rebound test, pull-out technique, dynamic testers, and also certain radioactive testers. Then what is the purposes of NDT? NDT is to estimating that inside, that is on-site compressive strength, and also it estimating the uniformity and homogeneity of the structure. It also estimating the quality in relation to the standard requirement. It also the detection of presence cracks, voids and other imperfections. It also identification of reinforcement profile and measurement of cover, bar dia, and also their spacing between the reinforcement, that also we can identify. And also that it conditions of pre-stressing, that is reinforcement steel with respect to the corrosion, chloride, sulfate, alkali content or degree of carbonation, we can measure it. Certain conditions of grouting in pre-stressing cable duct also we can use it. So in that non-destructive testing, so we have one more important test is the rebound hammer test. It is also known as a Swiss hammer or a rebound hammer or a concrete hammer test. It is a device to measure the elastic properties or a strength of concrete, mainly surface hardness and penetration resistance. Rebound hammer test is to be done to measure the compressive strength of existing building. Okay. The underlying principle of the rebounding hammer test is to the surface hardness, thereafter to check the strength of the particular area. Then how the testing will be? It consists of about the rebound hammer is a non-destructive testing apparatus whereby the rebound of the spring driven mass is measured after the impact on the concrete surface. You can see the surface of the column or of about a beam at the end of the concrete structure, while all around the corner we have to leave 50 mm, and also from each point we have to take it as a 25 mm center to center. See, the instrument, it consists of about the so plunger, so attached to the spring, and also it has a hammer with the indicator also we have provided. The output of the rebound hammer is referred as a rebound number, and it are correlated with the surface hardness of the concrete. Then how we can take that? On what basis? In the sense, suppose if we are going to testing in a column, take at least of about a 10 reading, and after that 10 reading, average of 10 will give the result. That means you can see in the picture, there are average of this 10 reading, so that we are going to calculate the average of 10, what we are getting, that is a strength of the particular structure. Then what do you mean by the quality control of the site? Of course, there are a lot of quality controls that we need to do. Since we are the engineers, we should take care of the quality. Then how the preparatory to construction will be taking place? First is preparatory of the construction, specification of concrete quality. First, you should check the concrete quality. Testing of material, how the material will be, what is going to be material. We need to check in the laboratory the chemical and also the physical properties of the ingredient. Mix proportion, of course, we need to decide that which kind of mix proportion is suitable for the particular type of structure. Inspection of approval, definitely we should inspect that, and then only we have to approve that. So these are the things we need to follow during the preparatory work of the construction. During the execution, we should check the constantly workability and also the strength test. That means we need to conduct the periodic tests of the slump cone and also the cube test. Next is the control of mixing, transporting, placing, compaction, etc. Definitely we should stand there and we should monitor the team to put a vibrator, to uniform vibrator all around the surface, method of mixings, and also the water content addition also. The testing of material of concrete testers and the frequency. Then fourth is the after construction, you have to control on the curing and also cube strength checking also, and certain NDT test if required. Thank you.